right. Welcome everyone to our technical discussion. And Tagim, you're going to start.
Uh, okay, hi everyone. This is the Fund7 decentralized SPO use case update. Um, so let's start. Okay, so the major tasks for this task that needed to be done to implement this use case were preparing a secure sandbox where the nodes can run, the Cardano nodes can run. For that, we chose Firecracker images because they are more secure and more jailed and more isolated than regular containers and much lightweight than regular virtual machines. So we started working with Firecracker images, with Firecracker virtual machines, and then created a few Firecracker golden images so that they could be used to run the nodes inside. So the whole idea of this decentralized SPO use case was to uh, enable one SPO on one machine to remotely deploy a Cardano node on a different machine through the NuNet network. Through that task, so the first one was creating the Firecracker images, which will be used to host those processes. The next one was to do an integration between the DMS and Firecracker so that the DMS, which is the device management service, the main component of NuNet, to be able to launch Firecracker virtual machines. So those have been implemented. The next important thing was to allow basically an SSH access to that virtual machine that was created on the user's machine. And for that, we had to go through the peer-to-peer network that was already created for the DMS and the metadata to communicate. So one setback on this point was all of the implementation that was performed was on the NuNet adapter, which is the networking module we are using until about 4 months ago, which is already depreciated right now. So after building this secure shell access just for the on the NuNet adapter module, we were doing some testing, and for that reason, we decided to switch to the P2P, and I will go into more detail about that. The other major task that needed to be done was persistent blockchain data, and this is because when a node is deployed on a machine, the first thing that the node does is to download whether that node is a passive or active one. So for example, a wallet like the address wallet, it will be a passive node, so it will download the entire blockchain data on the machine that it's running on, and then it will keep synchronizing and keeping a copy of the blockchain while it's running. So the one problem that we have to solve is when nodes are deployed on a machine, and let's say that and since those nodes, especially the ones SPOs manage, they need to be up 24/7 without any interruption. If there is any interruption on the machine that it was deployed on, we need to be able to switch the process to a different machine, but be able to preserve the data that was downloaded at first. So that downloading the entire blockchain data is not necessary. So it's not done again. Okay, so starting from the first one, as I explained earlier, there are Firecracker images that were created. This is the URL to the Firecracker images repository. There are a few of them. We initially started with Ubuntu and Debian images. We had a plan to switch to also make NixOS available. once the whole process was functional. The other functionality that needed to be implemented was, as I explained earlier, the DMS needs to be able to manage Firecracker virtual machines so that it's more isolated from the host system when the node is running on a machine that was onboarded to NuNet to provide compute power. Also, all these functionalities still remain. Things that were done on the NuNet adapter, the issue numbers are presented here. And the tasks done for the DMS and the Firecracker images, they are shown here. I can share these links later on. So the problem that was faced was unreliable P2P communication for the remote shell. There is an issue created for that. Can open it here for more detail. So yes, this was opened on January 17 when the issue was noticed. There is an explanation of why the nodes, why the communication between the two nodes is inefficient, and that's when we faced the problem with the networking. Can you please see my screen? Yes, right. Okay, so that's the problem that we faced. The one of the major things that created this problem was the library we were using for P2P communication called PyIPv8. It was a Python library, and we had this whole Python application called the NuNet adapter back then, which managed all of the networking. And we had the DMS, the device management service, handling things such as onboarding, um, user interface through a REST API. Basically the resulted DMS, the NuNet functionalities. So all the implementation related to P2P communication and remote shell went into this. Okay, can you see it's fine? No?
Yeah. Yes.
Okay. Okay. So this milestone for the P2P integration was completed about 3 days after we faced the issue. And once the P2P integration was done, the last task was to depreciate the NuNet adapter so that we don't need to have an extra layer of communication protocol, that is the DMS communicates with the NuNet adapter through certain APIs, and then the NuNet adapter communicates with other NuNet adapters, and so on. So yeah, the adapter was depreciated once the new network was integrated. So what's remaining is these two things. So we'd have to re-implement the networking for remote shell with the new network that we're using for the DMS. Now that the DMS is lighter and it's shipped by itself without any NuNet data container, we're going to need to implement all the remote shell functionality that was done earlier on the DMS with the new network. As for the blockchain data storage systems, we're going to have to look into a solution for that, and that one is still an open problem. So that's the report. If there are any questions, I think I can take them.
One thing I was going to ask is, once the the first GPU use case is complete, is the SPO use case going to be the main focus?
Yes, I would like to say yes, because efforts of I think have to be traded between the use cases that we're working on. Yeah.
Kabir says, maybe Dagim, you could explain what is needed to do more concretely on each item, or Zhao could explain the situation for persistence.
Okay. So the first thing with, at least I can explain the first one, since Joao was doing some research on the data persistence issue, I can take the first one. So about re-implementing the networking on the DMS, which was done for the metadata. That will be, I think, a less demanding task than it was before, at least this time, because one, the current networking is much more efficient than before. So, for example, I think this can be demonstrated with the EMS chat application. I'm not sure if the community here has seen a demo of that, but basically using the current DMS, it's possible to start a chat with another peer and to send messages with each other. So essentially, that's the basic implementation of the remote share, because what's needed is to have a quick send and receive of commands being sent and responses for those commands being received as quickly as possible, and also being encrypted while they're on transit. So currently the encryption is if when a new node is started in or joins the system, it has its own key pair, a public and private key, and then basically the public key is available for all the network members, so that when there is a communication between two nodes, then they can do symmetric encryption using the public key of the other, and vice versa. So what we need is encrypted communication, which is as efficient as the chat application on the DMS, which is quite functional. So that would be the first thing to do, and also creating new endpoints for the CLI interface, so that once the deployment has been created, the SPO, the user from the service provider side, can have access to the compute machine that is running the node.
So are you going to figure out how to open a session on the chat, or are you going to do this completely asynchronous, like signing each message back and forth?
Yeah, each message would be signed, and yeah.
All right. Okay. So yeah, I'm trying to figure out what is, let's say, complexity of this stuff in terms of time, or basically most of the things are implemented. And how much can you reuse the stuff that was done for NuNet adapter? It basically needs to be rewritten.
Some of the things they need to be rewritten, but the good thing about that is there was an extra layer of complexity with the metadata, because for example, for each new functionality that was written for the metadata, an interface for the DMS has to be written on both the DMS and the metadata. So let's say, so for example, with the remote shell, when it was implemented on the metadata, basically the communication of sending commands and then receiving responses would work fine. But then we would have to also implement an interface for the DMS so that it can send commands through the metadata to the other side, and then also implement an interface for the user so that they can use the DMS to communicate with the metadata, and then also with the virtual machine that's running remotely. So considering that, I would think it would be much less complexity and much less time than it took before.
All right. So, okay, maybe we can ask Zhao to say something about the storage part of it, also in terms of complexity and what's, let's say, missing.
Mm-hmm. Yeah. Can you hear me well?
Yes.
Okay. So for the last months, we've been researching for the possible decentralized storage solutions, and we've been researching IPFS basically, and we took a look on Filecoin also, but we saw some problems on Filecoin for our use case, so we decided to do our storage layer with and we are already implementing. So I split it on phases. The first one is already done, which is basically the whole treating of this IPFS thing as a plugin on DMS. We are dealing these IPFS parts as a plugin on DMS. So I was doing basically that part. And the second part will be on the compute provider machine and making the storage, pinning the data. And the third part, which is the most important, is the persistence. Like then we have to distribute the CIDs to other compute providers, and these other compute providers must retrieve the data and pin the content also. And yeah, so I think that's the situation now. We are in the middle of the implementation, and yeah.
All right. So actually, I was thinking, would it be? Do we have Janina here?
Yes, I'm here.
So do you think it makes sense to just display all this the technical dependency chat that was kind of and with which we ended up, and just to go over it and to see the big picture?
Okay, we can do that.
All right. So would you like me to do that?
Yes, if you
Right.
can, please.
Yeah, that's right. So
By the way, Dagin, can you explain again how is this data storage layer needed on this SPO use case? I mean, I understood that compute providers needs to download the blockchain. Uh, what else? They need to persist the blockchain situation.
Yes. So when SPOs are running nodes, they would like to keep them online without any interruption. So in order to handle that, we would have to switch over the process to a different machine. Let's say if the first machine that was running the process is unavailable, or let's say if it goes down for some reason, it needs to be restarted somewhere else. The thing is, when the restarting somewhere else, then we're going to have to download around 50 gigabytes of blockchain data whenever that happens. So that's the reason for it.
Okay. Thanks.
right. So just to kind of try to I don't know, to see a big picture. Do you see my screen?
Yes.
So basically, this is a milestone that the configuration that we had when we probably had this decision to go to libp2p. But what understood, okay, estimate the price to run a Cardano node. This is a general thing for public alpha that we will be doing I mean the estimation of the compute resource. Now here data persistence. This is precisely what Joao just said. Then build firecracker image. I believe we kind of already have this, so this is done. Please, Dagin, please sort of, say whether I'm correct or not.
Yes, so it's good.
And then what is needed is another branch, which is remote shell access, which has to be what you explained, to port from what we had with NuNet adapter, which was kind of unstable, working but unstable, to now to basically having just a DNS. And okay. So, and then we have secure sandbox for user provided compute device. Now, I'm not sure I understand this because that's related to firecracker image. So how is it different? Janina, could you explain?
Here, this task is to take a new look, review if we need to think about security on the whole process. So we have the security on Firecracker, as you said, but this is for us to review all the workflow to see if we have to implement or reinforce security.
And so how much do you think this is covered by other tasks in the public alpha? Because we have a huge
Yes, we have similarity here. Yes, what we are doing for public alpha will be used here too.
All right. So, okay, it's clear for me. Anybody has any other questions? I mean, I think, well, basically the consensus is that we have to finish public alpha with all the sort of new things that we implemented and functionalities, and then to take this back and to adapt everything to public alpha and to sort of put what's missing. So, yeah. All right, so back to you, Dagan.
Okay, I'm actually done on my side. If there are any questions, I can take them.
Yeah, I have a question regarding the SPO. So, the whole problem here, like the second parts, the data parts, the problem is regarding resume the job, right? Basically, like if a node goes offline, then sorry.
Sorry, go ahead.
So the whole problem on the data side for the SQL use case is job resume, basically, right? The
I'm sorry,
game.
can you repeat that, please?
Yeah. So regarding the data parts on the SQL use case, the basically problem here is job resume. We have to resume the job on another node when one goes offline, right? And we need the blockchain data.
Yes.
Okay, but I was thinking, if we have like all the compute providers that enabled the SPO use case running the Cardano nodes, then every one of them would have the Cardano blockchain data. Then if we need to resume the job, we just need to look for nodes that are already running the Cardano nodes, and they already have.
Running a Cardano node is pretty resource intensive. I assume it would only be compensated with NTX when a stake pool operator is using it, right? So I'm not sure if compute providers would want to opt in to run a node if
Okay.
they're not going to be.
Okay,
Obviously,
so the problem. Hmm. Go ahead.
well,
Sorry.
one possibility, and I've already suggested this to Dagim, is to allow stake pool operators to pay to run their nodes on multiple devices. That way, if one of them fails, there are backups. But in that
Hmm.
case, of course, the stake pool operator has to pay for multiple nodes. Otherwise, if you just have a lot of compute provider running nodes and not being compensated, they probably wouldn't want to do that.
Yeah,
Yeah.
just to add a little bit more to that. There are ways that we can avoid, actually not avoid, but at least prolong the second problem being a problem. So for example, one thing could be there can be dedicated machines for running CADA nodes, which we can guarantee will be online at least for a significant amount of time, for the majority of time. And there is running multiple machines, as Mark said.
All right. Perfect then. Thank you everyone for attending and see you.